Okay, class, today we're going to talk about graphing. Okay, so let's review our parts of a graph like we did the other day. Okay, we know in a coordinate grid, we know that it's divided into 4 chunks, and we know that those chunks are called quadrants. So the first quadrant is the top right hand, so that's going to be quadrant 1, and we identify them with Roman numerals. Quadrant 2 will be the one on the top left, quadrant 3 will be the one on the bottom left, and quadrant 4 will be the one on the bottom right. We know basically what happens is you identify quadrants based on the letter C. Again, that's how they go. Okay, each line, there's lines in the middle where the horizontal line is what we call the x-axis. The vertical line, the one going up and down, is called the y-axis. And we know that point in the middle is called the origin. Now, each of these points can be identified by a coordinate. So this coordinate right here is going to be over 3, up 7. And so we would write that as positive 3, positive 7. Now this second coordinate is we go over 5 and we go up 5. So since I'm going to the left, that becomes a negative 5. And then the up 5 is a positive 5. So the coordinates in quadrant 1, we know are always going to be positive, positive. The coordinates in quadrant 2 are going to be negative, positive. In quadrant 3 are going to be negative, negative. And in quadrant 4, they're going to be positive, negative. So that's what our graphing is about. So right now what we're doing is we're looking at this standard. This is a 7th grade standard. We're representing excuse me about that. We're representing linear relationships using verbal descriptions. That's the reading and writing expressions. With tables, that's going to be our t-charts. Okay, graphs is what we're talking about today. And over the next few weeks, we're going to be talking about equations that simplify to the form of y equals mx plus b. Okay, but today we're going to focus on graphing. So far, if you paid close attention to what we've been doing, we've been evaluating expressions, and we've done them a few ways. The first way, I gave you values of the variables, and then I changed the expressions. So that's when I gave you static values for A, B, and C, and then gave you a bunch of expressions to use to evaluate with. Okay, the other way is I've given you one expression and asked you to evaluate it for various values. Now, what we used to organize our data was a t-chart, and that was the reason why what algebra is all about is we're looking for patterns. And when we organize our data into a t-chart, we can then see those patterns a lot better. So let's take a look at that first question that you did on your homework. Okay, so this was our expression. This was our t-chart. So what I have you do is I have you show me the work for the first 3 x values. So this one says, if x is negative 2, then x plus 4 is what? Okay, and so we have to find that. So we take that negative 2, we plug it into our x plus 4, because that means I'm going to take whatever x is and add 4 to it. So negative 2 plus 4 gives me 2. And then I go to the next one, because x now changes to a negative 1. So I do negative 1 plus 4, which gives me 3. Then I do 0 plus 4, which gives me 4. Okay, so you have to show your work the first 3 times, because then that establishes a pattern. So what are we doing going from one number to the next? We're adding 1 each time. We're increasing by 1. So to go to the next one, I'm going to increase by 1 to get a 5, and then increase 1 to get a 6. So as long as there's a pattern here on the right-hand side, there's going to be a pattern over here on the left-hand side as well. Okay, and that's what we got to remember. Now today what we do is we get to learn why we evaluate things in a t-chart. Well, we know this first side is called an x. Well, the only other time that we've dealt with x's so far has been when we're dealing with coordinates, okay? But the x also has another number that accompanies it, which we call a y, okay? Well, I'm here to tell you this side is called the y value. So what you do whenever you create a t-chart, when you fill that in, is you're creating a set of coordinates that creates a picture, okay? So when we look at this, we're going to draw a graph. Okay, I'm going to put some tick marks on it. Okay, so I'm going to put, let's see, 3 tick marks going to the left, 3 tick marks going to the right. I'll do 4 that time. And I'm going to do 7 tick marks going up. Now, let's see, that one didn't do very good, so I'm going to redo it. Okay, so I've got 7 tick marks going up. Now, I don't need any going down. There's a reason for that, and we'll talk about that in a second. Okay, but this is what we're basically doing. What you do when you create a T-chart is you create a series of coordinates. And if you graph those coordinates, they then make a picture. So let's do that. This first coordinate is -2, 2. So that means I'm going to go left 2, up 2, and I'm going to put a dot. The next one says I'm going to go left 1, up 3, and I'm going to put a dot. The next one says I'm going to go right or left, none, but I'm going to go up 4 and put a dot. Now, what do you notice so far? Looks like all those points are lying right on a line. Okay, so if we do the next one, you get +1, +5, so right 1, up 5, and then right 2, up 6. And you'll notice that those look like they're lying on a line. But let me ask you something. Our T-chart is just kind of a small representation of what this looks like. Could I have values that are between 0 and 1, like maybe 0.5, or maybe 0.1, or 0.001? Could I have values in between that? Yes, and if I were to plug those values into my expression, I would get a corresponding y value. Okay, so that means that in between any of these 2 points that you see, you're going to have another point. Okay, so in order to finish this graph out, we don't just draw the points, or we don't just put the points on the graph. We have to actually represent the entire picture. And for every expression that we do in 7th and 8th grade, it makes a line. Okay, so what we do to finish this problem is we're going to play connect the dots and extend that all the way out on both ends with arrows. Now that is the picture of x plus 4. Now the one thing you need to understand is that x plus 4 is the only graph that looks like that right there. Now there will be graphs that will look similar, very similar, but none that look exactly like x plus 4. Okay, so that's the reason why we organize our data in a T-chart, because it creates a set of coordinates for us to graph so that we can create the image of what each of those expressions looks like. So let's try another one. Here's number 3, okay, off of your homework. Now this particular one just said 2 times x. So that's exactly what we're going to do. 2 times x. And then this first time, the x is -2. So 2 times -2 gives me -4. Then I go to the next one. 2 times -1. Well, 2 times -1 gives me -2. And then 2 times 0 gives me 2. Gives me 0, excuse me. So what am I doing on this one? What am I doing? What am I counting by? Increasing by 2, increasing by 2. So what would I do to go to the next one? Increase by 2 to give me the 2, and then 4. Now, for the purposes of our assignment, you're going to see a graph that looks just like this. Okay, in class, I'm going to give you a set of graphs that look just like this to help you graph it. Okay, so in this one right here, we're going to graph our coordinates. We're going to start at the origin. We're going to go -2, -4. So -2, -4 goes right there. And then -1, -2. And then 0, 0, which is the origin. And then 1, 2. And then 2, 4. Now, if your points do not lie on a line, then something went wrong. Because all the ones that we're going to do today, for sure, are going to be a line. So all of our points look like they lie on a line. So to finish this out, we're going to play connect the dots, extend out past on the top, and then come back and extend out past on the bottom. And that's the picture of 2x. Now, do you notice any differences between that graph and the previous graph? Hopefully what you found out, what you notice is that this graph on 2x is much steeper. Okay, it is steeper than the other one, right? So let's try another graph. Let's do one more together, and then we'll have you do one on your own. And it's going to be a tricky one. Okay, so on this one right here, it says 3x minus 3. So again, yes, we do have to still show our work for the first 3x values. So we're going to do, we'll change my minus first. Okay, and I'm going to do 3 times -2 plus -3. Well, 3 times -2 gives me -6, plus -3 gives me a -9. So then I move on to the next x value. 3 times -1 plus -3. So 3 times -1 gives me -3, plus -3 gives me -6. And then the last one to show work, 3 times 0 plus -3. Well, 3 times 0 is 0, plus -3 gives me -3. So what am I actually doing pattern-wise right here? I'm increasing by 3. So if I increase by 3 one more time, I'm going to get 0 and 3. And now what we need to do is create our picture, because this is our set of coordinates of x and y. And so now we do -2, -9. Okay, so -2, -9 is to the next to the last spot because I know it's a graph that's got 10 lines on both ends. Okay, so then I got -1, -6. So 1, 2, 3, 4, 5, 6. And then 0, -3. And then 1, 0. And then 2, 3. And again, those points should lie on a line. And again, this one goes even steeper than the previous one. But all of those pretty much look similar, but they're not identical. They're not exact. So what if I gave you a negative? How do you think that's going to change? If you remember correctly, that when we had a negative on the expressions, that went from increasing to decreasing. What do you think that's going to do to the graph? Well, let's find out. So this one says it's got -2 times x. So that means it's going to be -2 times -2, which gives me 4. -2 times -1, which gives me 2. -2 times 0, which gives me 0. So what am I doing? I'm decreasing by 2. So this will be a -2, -4. So when we graph that, do you think that's going to affect the graph? Well, let's find out. So -2 means left 2, up 4. The next one says left 1, up 2. Next one says origin. Next one is 1, down 2. And then 2, down 4. So hopefully you notice that your graph is now going the opposite direction. Instead of going uphill, it's going downhill. So when we had expressions that had a positive coefficient, my numbers were increasing. So my graph was increasing. It was going uphill. When my coefficient is negative, my graph is decreasing because my values are decreasing. And decreasing means go downhill. Okay? So what you're going to do on your assignment today is the same exact thing. I'm going to give you 6 expressions. Okay? And I'm going to give you 3 blanks that you got to fill in your work. And what I need you to do is complete the t-chart and then graph each t-chart. So in this first one, you got x plus 2. The next one, x minus 3. X plus -4. 2x plus 1, -2x minus 3, and then the trickiest one of them all, x over 2 plus 1. But again, in this one, please note that I have changed your values for x. Okay, so make sure you pay attention to that. So that's what we're doing with our expressions now. So we've kind of hit several things on this standard. We understand how to write verbal descriptions. That's your reading and writing expressions. We know how to complete a t-chart, which is we call a table. And now we know that those tables actually create graphs. It's kind of cool when you think about it. And with all of these, this is what we use in algebra to help make predictions of what's going to happen next. So until next time, I'll talk to you later.